Welcome to LNP Renewable System Integrator. Today we are going to discuss about the ship automation basics part 20 of 22. If you have missed part 1 to 19, please subscribe to our channel. In our channel, we had created a playlist ship automation basics part 1 to 22. So in the part 22, we are going to study briefly about the PLCs, that is programmable logic controllers. So in this part, at the end of the session, we will find the answers for the following question. What are the input and output sections of a PLC and what are the features of a PLC inputs and output? So we are going to see the example of analog input and output devices and also how a discrete or a digital input and output devices are powered, how a PLC local remote module racks are connected, and what are the examples of digital input and output devices, how we need to address in the ladder logic. Okay, how a PLC temperature measuring device is connected with the analog module, how field devices are connected with the fixed type PLC modules, how a PLC works with little example, how to do wiring for PLCs, how to create a redundancy network for the PLCs, how a buzzer, push button, alarm button, sensor, transmitters in chip looks like. So in our discussions, we might be using so many symbols, short forms and abbreviations to represent the instruments for measurement and indication, circuit breakers, connection, generator and transformers, fuses and circuit breakers, protection monitoring relays, switches, relay contactors, units and divers. Okay, so this is the Siemens logo PLC. This is how it looks like. It's a very smallest one, and these are some of the extension module. Okay, we have extension module in digital module as well as the analog module. We had given you both an example. Okay, this is how it looks like. If you're planning for a training, we can provide you the training. Okay, so our kit is entirely different. In our kit, we have the PLC modules. We'll have a power supply to energize. We have Ethernet connections. If you're planning for drive, then you can have a drive. Okay, so this is the fixed type one, and this is the modular type one. So this is how it looks like. Okay, in the modular type we have a slots. We can remove the required modules and we can insert the required modules in it. Okay, so as we told earlier, mostly for some certain equipments, since we have very less number of IOs, instead of going for a new CPUs, it is better to use the remote IO modules, because one in certain applications equipment will be located in one place, but the control panel of the entire plant will be located in some other location. In order to monitor only that particular equipment, instead of going for CPU with the analog model, we can go with only the remote IO modules. We can establish a network connection between these master and the slave units using the network cables. So if we get into the input and output section, most importantly, okay, same like our computer, okay, this PLC has a CPU, central processing unit, and it has a memory, RAM, that is random access memory. Then for the entire system to work, it needs a power supply. Okay, and if you categorize the IO module, input and output module, we have input and output module, digital input and output module. It can also be referred as a discrete input and output module. Then we also have analog input and output devices. In order to establish a communication, we have a communication interface in a PLC. Using that, we can establish a communication between our PC, which has an installed software, which can, through that we can able to communicate with the PLCs. Okay. So most importantly, okay, in the input module, you will connect all the input sensing devices. It will be a push button. Okay. It will be a relay. Okay. And if you get into the output, in our output, we might be connecting our loads like motors, actuators, buzzers, lights. Okay, most importantly, in both input and the output sensing set, we'll have an isolation. It can be an optical isolation. So now when we get in depth into the analog input and output devices, example, a level transmitter is an example of an analog input. Temperature sensor, pressure sensor, these sensors will come into the category of analog signals. Okay, now in the same way, if you try to represent the level transmitter signal in a level indicator, it is an analog output. Okay, and also one more example, we can say the valve. Okay, the modulating valve, because in the modulating valve, we will go through two things. One is we'll have an analog input signal also, we have analog. Say for example, if you are controlling a valve, okay, you will try to provide some analog output. It can be 4 to 20 milliamps or 0 to 10 volt. In the same time, if you want to have a confirmation that it had operated as per your command, as per your control. So in order to monitor it, you will try to take the feedback. That feedback you can consider it as an analog input. So as we told earlier, we have a backplane power. So we can insert our modules in it. So this is a simple example. See here, we have a motor, start and stop button. So it is a high equipment. Okay, like the same, we have so many equipment in the same location. But unfortunately, only one of the equipment in the industry which is being located at a very remote location. Okay, so we cannot put separate processors or CPUs for that. So instead of that, what we will do, we will put only the remote IO modules where it will have a power supply, input and output modules. We will connect that electric load equipments only with the remote IO. Through the communication, we will try to establish a PLC remote input and output communication. Okay. Next, now when we categorize, okay, the PLC digital inputs and output, okay, we'll have a digital input equipments like indicator light, okay, signaling column, relays, motor starters. Okay, now when we get into the output devices, okay, we will have a LED. No, sorry, we will have a select. When we try to know the digital input devices, okay, it will be selector switches, okay, limit switches, proximity switches. All these switches comes into the digital input, whereas in case of digital output, it will be indicating lights, signaling columns, relays and motor starters. Apart from it, there are three different types of PLC output. It can be a relay, it can be through triac, or it can be through transistors. Okay, and most importantly, apart from digital input and output, we also have modules for analog input, okay, which will be operated with RTD, analog input module for TC, analog input module for 4 to 20 milliamps, digital output module, analog output module for 0 to 10 volt, and analog output module for 0 to 20 milliamps. So this is a simple way how a PLC ladder diagram with the addressing schema. So most importantly, when you see an example at the right hand side, we have a motor. So motor, most importantly, it will come in the category of output. Okay, now we have a pressure sensor switch, temperature switch, and also we have a manual push button. So all these three we can take it as a input, most importantly digital inputs. Okay, and now, so in the same way, now we had categorized the existing equipment into two categories, input and output. Now we are going to draw the diagram. Okay, so now we have a relay diagram first, then we are converting the relay diagram into ladder diagram. We'll have a 24 volt and a 0 volt. Okay, so what will happen now? We will assign the three different input addresses for all the three switches: pressure switches, temperature switches, and manual switches. So based on the different manufacturer, this addressing schema will differ. Now when we get into the output, for output coil also we need to assign a output addresses. So now we have given a generalized address, but based on the different manufacturers, Siemens, Allen Bradley, Delta, the addressing methodology, G-Fanuc, Mitsubishi, the addressing type will be different. Okay, the addressing methodology that we are using will be different. So this is a simple example how a fixed PLC modular looks like. See here the same example that we saw in the previous slide. We are representing it with a input and output connections in a PLC. See here, this is a fixed type module. We have an input connections terminals and output connection terminals. In our output, we are connecting the motors. In our input, we are connecting our pressure switch, temperature switch, and push buttons. But most importantly, whenever you are trying to provide the line, try to provide with the fuse, so that if any mishappening happens, the fuse will get blown, so that you can protect your PLC modules. Okay. So this is how we need to do the power wiring for a PLC. Okay, and this is how we need to connect our IO devices with the PLC. See here, we have a PLC, we have a programming cable which got connected with the PLC. Okay, we have a 24 volts power supply for the PLC to work, and we have the fixed type input and output terminals. In the input terminal, we will connect the input devices. In our output terminal, we will connect the output devices. In the same way, if you get in depth into the advanced models, we have control relays, we have UPS supply to convert the 230 to 24 volt. Next, this is a simple example how we can do the wiring for a motor to run. Okay, so see here we have a start command, so it is a digital output. We have a stop command, it is also a digital output. We have a permissive command, it is also a digital output. Now in the same motor feeder, okay, we are going to monitor the local and remote statuses and run status. These are all feedback signals, okay, volt free contact signals. So that will get connected to the digital inputs. Apart from it, we have a protection circuits, that is vibration contact, overload contact, and temperature contact. If any mishappening happens, okay, if anything happen, immediately with the help of these switches we can identify and we can switch off the entire plant. Okay, now when we get into the programmable logic controllers, basically we need to know what is the NO contact, that is normally open input contact, normally close input contact, and most importantly output coil, that is Q. Now apart from it, we will be discussing more thing about the logical circuits. It can be a OR logic function or it can be an AND logic function. So we had given you a ladder diagram, truth table, ladder logic, and a functional block of a OR logic. And also we had given for AND logic, ladder diagram, truth table, okay, ladder logic, and AND function. So apart from it, if you go for a NOT function also, we have a ladder diagram and a ladder logic, okay, and we have a truth table and functional block. In the same way for NAND, we have a ladder diagram, truth table, ladder logic, and a function block diagram. And NOR function we can represent like this in the ladder diagram, okay, and for exclusive OR we can represent our ladder logic, truth table, and function block like this. Okay, since it's a brief section, we are just giving you a brief intro only about the PLCs. If you really want to know in detail about these things, please do a course with us. We are providing PLC programming training for Siemens, Allen Bradley, and Delta PLCs. Okay, this is an example how we can represent a DOIL starter in a logo shaft PLC as a logical circuit. Okay, this is how we need to make our wiring. Okay, we are connecting our input and output push buttons in the input module. Okay, and through the contactors we are trying to control our motor. So this is some of the best examples how in the PLCs, how we for the propellers we can provide a PLC, how it looks like. For the generator monitoring we have a PLC. For anti-healing we have a PLC. Okay, and most importantly we need to know the professional definition of MAS, that is maritime automation surface ships, okay, which can operate independent of human interaction. That is the advantage of this MAS. We have so many level of autonomy technically: A0, A1, A2, A3. A0 is a manual one, A1 is a dedicated one, A2 is a supervised one, A3 is a fully automated one. And when we get into the level of automation, we have B0 level and B1 level. B0 is a no qualified operator on board. B1 is a qualified operator on board connection. Okay, so we had given you a table which represents a different technical level of autonomies which are available in the market. Okay, now when we go for the operation supervisor level, okay, we have levels from OP1, 2, 3, RO1, RO2, RO3. Okay, OP1 is a continuous supervision on the onboard vessels. Okay, OP2 is a periodic supervision on onboard vessels. OP3 as needed basis on onboard vessels, and RO1 is a continuous supervision of remote location. RO2 is a periodic supervision of remote location. RO3 as needed basis remote location. Okay, so when we have let us have an example of combination of AOS, ROS, and a fallback. That is scope of automation. Okay, scope of remote control and fallback executor. Okay, ROC here refers to remote operation control, and CS here refers to the computer system which executes all and shared execution. So as we mentioned earlier, okay, there are certain factors. Okay, based on that we are classifying the automation levels, mainly based on these control modes. One is the presence or absence of the function that provide information support, requirement of a human approval prior to action, transition from human to system as a entity executing the control, presence or absence of means of intervention, reporting of control a result to a human. Next, following factors also we are taking into consideration. okay, in the control mode, that is a requirement of a continuous supervision and presence or absence of operator and their location. So these are all the important conditions. Okay, when you're making automation level, you need to keep all these things in mind. Okay, so this is an overview of a ship. Okay, in our ship we have so many automation equipment, especially we are doing ship management, alarm monitoring, okay, condition monitoring system, rudder control, ROV, stabilization system, thrusters, everything we are controlling in the ship. So in bridge alone, we are doing alarm and monitoring, we are doing simulation, we are doing a cruise control, we are making a autopilot mode. So even in the cabin, we have a information system, extended alarm and monitoring system. In a deck, we have trenches, ROVs, winches, gangways. And when we get into the machine control room, we have rudder control, okay, alarm and monitoring, energy management, drive control, ship automation in general, diesel, electric drive control, and transient recorders. But when we get into the machine or a cargo room, we have a anchor and winch control, ballast compensation control, okay, conditioning monitoring, motor control, fuel conditioning, process control, and water treatment. All these things are being controlled using the PLCs inside the ship. So that's why ship automation plays a very important role in controlling most of the things in bridge, cabin, deck, machine control room, and cargo rooms. Okay, so this is a typical graphical view, okay, of the external ship. See, these are some of the components of alarm system. We have components for automation. We have a tank level sensors, temperature sensors, pressure meters. We have a limited emergency level alarms, ultrasound level alarms, okay, pressure transmitters, temperature transmitters, and also we have ultrasonic multipath flow meters. Okay, most importantly, if we have plan for a TSS control, it is a integrated control system for technical means of vessels. Okay, we have a following mechanism. We can do ballast drainage system, compressed air system, fuel system, wastewater system, HVAC, that is ventilation air conditioning system, electrical power system, diesel generators, and main engines. Okay, we also have a standby mode, that is redundancy is very much important. Even if it's a ship, we need a redundancy, because in that we will have a two master CPUs. Okay, if anything one fails, the other will take over the function. Next, even apart from it, we also have the network redundancy also. If any one of the network fails, using the other network, we can establish the communication. This is a simple example, okay, which shows how a safety network 1 and 2, okay, if one important master CPU fails, the other CPU will take the control and it will try to control all the slave stations. We also have emergency stop functions. And if any of the slave station works, okay, so those master CPU will take over the control of the existing slave station and it will try to control the load equipments. Okay, this is a system architecture and overall view of a ship. We have roof of wheelhouse, we have CC console room, we have COS panels, we have onshore services. For sure, we need an internet to establish network between different equipments which are located in remote location. We have a console in CCR. We have a local ME control room. We have a radio remote control. Okay. Apart from it, okay, we have a TSS alarm system for cargo, UPS cabinet. We have a BMS control. Okay. We have a light and sound columns. We have a tank level sensors, and also we have set of sensors to establish an alarm when in case of any sort of emergencies and mishappenings. Even we are monitoring each and every valve. Okay, this is a schematic diagram of a deflecting measuring system, and this is a flow chart of how a TSS or a cargo system looks like. And this is the diagram of a tank with the gas. We are monitoring the temperature using the temperature sensor. We are monitoring the level using the level transmitter, and if there occurs any issues, with the help of the level transmitters, we can trace the level alarms. This is a flowchart of TSS alarm systems, and this is the flowchart of TSS alarm system T. Okay, and this is a block diagram of the fuel consumption monitoring system using a 24-volt power supply. Through the GPS receivers and indicators, we are monitoring all the fuel tanks, cargo heating boilers, utility boilers, diesel generators. and we are using the flow meters to monitor the flows as well. Next, this is a flowchart of the bridge alarm system. We have different stages of alarms. We are monitoring each and every rooms using these alarms. And this is a watch alarm system. This is how it looks like. This is a flowchart, and this is a real-time watch alarm control panel. Okay, dogs. This is how it looks like, and these are some of the buzzers and acknowledgement push buttons. This is a real-time alarm button and a dog set in suspended version, and this is a control panel. Okay, it is installed in the vessel control room for navigating the bridges, and these are the real-time photos of ultrasonic level alarms. Okay, pressure transmitters, temperature transmitters, and ultrasonic flow meters. This is a remote control on a project. Okay, so we can monitor everything from here. So these are the emergency alarm systems. We have so many different modes. We have manual mode, man overboard, radiation hazard, gas alarm, shipwide. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We can provide the contact details here. We are providing PLC programming training for Siemens, Allen Bradley, and Delta PLCs. And most importantly, if you have a plan to work in the GCC countries, especially if you are really interested to work in marine as a ship automation engineer, ship automation specialist, then there is a possibility for it. So we are providing training for building management system, building automation control system, and ship automation also. If you are really interested to know establish a solar DC lighting system in a place where EB power is not available, then you can refer this. You can contact us. We can help you out. And most importantly, you might have an agriculture farms. If you want to protect your crops from the animal intrusions, instead of going for electrical fencing, you can use the solar fencing. We are providing solar fencing as a kit. And also we are providing solar on-grid, off-grid, hybrid application, solar street lights, and solar pump services, design, installation, testing and commissioning, consultancy, and training supports. If you are really interested to know the access control basics and electrical vehicle basics, you can contact us. We had provided our contact details here. Thank you so much.